We have to do it again. Hi, Joyce.
Hey, Joyce.
Hi, Joyce.
Okay, so we started off today by doing, Joyce, if I were you, I would pause this and then go ahead and work out each of these problems. So pause it now and try each of these in the back of your spiral. Okay, now you're starting the video again because you already paused and tried them. Our final answers that we got were, can you guys help me out?
Oh,
C,
C,
B,
E,
E,
and
C.
C.
Okay. They went ahead and collaborated, so Joyce, go ahead and check those. If you have questions, you know how to find me and ask me. But then we talked about, okay, piecewise functions. If it was tricky at all, let's do a quick recap and just kind of say, all right, this is how we deal with limits to piecewise functions. So, if x is not approaching a separator, what's a separator again?
Domain thingy. X is
Kind
less
of, like a value that's in one of the inequalities is one of the boundaries for one of the pieces.
Yeah.
Then just plug it in, no big deal. So, you guys, be creative. I made Calculus AB do this a little bit. Make up a problem. The limit as, I'll give you a value, the limit as x approaches 2 of f of x equals, but you guys, someone confidently, give me a piecewise function where all we would have to do is plug it in.
X minus 2 and x cannot equal 2.
Or x cannot equal 7.
Oh, 7? That works.
Why 7?
Because, why not?
Okay.
But hold on, it's a piecewise. We need more pieces.
Square root
Oh, that's
x cubed over...
good. Oh my gosh.
wait, inside the square root or outside the square root?
Or x.
Wow.
Inside or outside
Right.
the square root? We should make it the whole thing,
For everything else.
just to be savage.
No. How about x minus
I mean,
2
yeah,
for x equals 7? That way it's just a point.
Oh, okay.
Okay,
That
we'll
would be
switch
Let's
better.
make this one more fun, because you wanted everything else anyway.
Yeah.
Alright, so hold on. I didn't like my square root.
You didn't like your square root. I wish I had those problems.
First world problems.
Okay. So, we have that given function. Limit as x approaches 2 of f of x is... Where do we plug it in? Which piece?
To top? Either
No,
or.
because the top is only for 7, and we're approaching
2
2. So where do we plug it in?
to the bottom,
Bottom.
to the bottom.
To the bottom. So we have the square root of 2 cubed all over 4 times 2 is 8.
2
and then
root 2 over 8, so that would be root 2 over 4. No. Yes.
Can we do that?
Yeah.
No.
Yes.
No, you can't, because you can pull out a 4 and
You could do it the other way as well.
Do that too.
We could also say 4 root 2.
So 4
yeah.
root
So
2.
also
No, 2 root 2.
Yeah, 2 root 2.
So that'd be root 2 over 4.
Almost.
'Kay.
Unit circle.
Almost.
Almost.
If x is approaching a separator, let's do something like the limit. As x approaches 1 of f of x. Alright, Amanda and Gerardo can't speak. Someone else, give me a function
ln x plus 1.
that has, they cannot have equals or not equals in it.
Okay, so 2 minus x.
2 minus x.
X is less than or equal to 1.
Right.
Okay?
And then
Does
x
that
over
not
2
solve
plus
the
1
Other question.
Yeah. And x
such that x is greater than 1.
Nice.
Good one.
Alright, this limit will only exist if, what do we have to test? The one-sided limits exist, right? So limit as x approaches 1 negative, where are we going to plug that into?
The
Top.
top one.
The top, which is going to be 2 minus x, which equals
1.
1. Remember, that's not a negative, that's from the left. Then we have to compare that to the limit as x approaches 1 from the
Right.
right of 2, not of 2 minus x though. If it's from the right,
Of the bottom one.
it's above, so it's x over 2 plus 1, which equals
3 halves.
3 halves. So the limit is,
D&E.
Non-existent.
Non-existent.
the
Sorry.
limit is non-existent, hence the limit does not, I didn't put in equals, haha, does not exist.
Because we're gangsters.
Wait a minute.
Nice, look at you guys making up problems, you could teach calculus.
Yeah, we got problems.
Miss D.
So,
That was hard.
if the one-sided limits agree, the limit exists, right? And then, if the one-sided limits do not agree,
D&E?
D&E.
the limit DNE. L-I-N-E, or is non-existent.
Could you say L-I-M-D-N-E because DNA?
So, section. Interesting.
He was trying to say, George, drink bleach because my words give you
No, it's okay. It's like
stomach
Jonathan
ulcers.
Reeves.
George is
Jonathan
gonna have
Reeves
fun with what we're
loves-
saying.
He wants to make AppCab something new.
AppCab?
What's AppCap? Oh.
AP Calc AB.
Oh.
He wrote it on the side. He was like, AppCab, I'm gonna make it a thing. I was like, okay.
If it does,
For
Your guys' doesn't work.
app.
Let's see.
App because.
Never mind.
App because.
Never mind.
Yes.
Never mind. Conversation for another day?
No. I'll tell you after.
Okay.
So I can get away with it.
Misty, can I give a funny story about the word infinity?
No, it's okay.
As long as we're writing.
No, Joyce will be mad.
Okay.
She's not gonna want to hear your
How
sad
funny
tales.
is it?
It was pretty funny. My sister was
Is it
dying.
Gerardo funny or is it?
First, his sister was dying. Let's try. Okay,
His
so
sister was dying. That was probably because he like shanked her.
no.
No.
Joyce is gonna
That would be
have fun.
inappropriate. Jordan, go.
Okay, so we were watching
And illegal.
we were watching Secret Life of Pets, and there was like a
Oh, the joke?
no.
Okay, focus.
We were watching. There was a preview for the singer, and at the bottom it said number 1 to infinity, and I thought it said number 1 to infidelity. So when I told my sister that she was dying, because it was like this pop singer.
Yeah, this random,
Yeah.
which it's pretty funny. I won't lie.
I gotta go somewhere. I just gotta take care of some family business. I'll be back. Maybe.
But if all people Gerardo, then let's read infinity.
How many lines should we skip?
Because it wasn't the symbol. Let's go ahead and just fill it in.
Okay, sweet.
Think about it. What are all the different possible limits as x approaches positive or negative infinity?
A constant.
1 over
No.
x squared.
Yeah, I can approach constant, right?
Mm-hmm.
A constant, positive or negative infinity, and
Oh, I got one.
D&E. Right?
Wait, hold on.
What am I missing?
D&E.
Mm-hmm. Hold on.
Oh,
You don't have to erase yours. I'm just rewriting mine.
I can't erase mine. I'm using pen.
That was smart.
Did you take up the entire page though?
No.
Oh, then just keep writing. See, I just ran out of room. Okay, give an example for each. Oh, look at you guys. All this creative energy.
1 over x.
For which one?
The first one.
Oh, I got one. Okay, x squared plus 2x minus 3 over x squared
No,
plus
that's approaching
5.
infinity, huh?
What is that?
No, it's
Letter
approaching
or
0.
sign?
L.
Oh, it's just an L.
And L stands for
The limit.
limit. Stands for constant.
Oh, got it. Okay.
Oh, that's an L?
I thought it was a less than.
I know, me too.
Is that better?
1 over x is approaching constant, right? Not infinity? Or is it approaching infinity?
Good question.
No,
Okay,
it's
the limit.
Approaching 0, right?
Hold on. The limit as x approaches positive infinity.
Oh, it's approaching 0.
Yeah, it's approaching 0.
We'll say that's f of x. Of f of x. And the limit as x approaches negative infinity. Wait, we should actually think of them separately? Yes, because
0 and
remember,
negative 0.
sometimes they're different answers. So 1 over x does have limits of, well, that's exciting, but is 0 constant?
Yeah, technically.
Can we have a little more fun with it?
Yes, please.
Okay. What if I was to do something like,
Oh, I remember this. This was a pain.
That one's fun.
It's
Because you can think of it as a horizontal asymptote, but it's not really a horizontal
Yeah, he's
asymptote, so it's approaching 1.
what did you just say? Now you're making
That's
one
true.
bleach.
And if you're going to negative infinity, it's going to be still 1, right? Because the negative and negative.
It's -1 because 1 is going to be negative sign change.
because if you plug in a
because the
negative,
top
that's
is
a negative and that's a positive. If you plug in a positive, that's a positive, that's a positive.
Isn't that just technically x over absolute value of x? You can just simplify it as that's the.
You can't totally simplify it as that because you have the plus 1.
But as you go infinity, 1 plus 1 is irrelevant.
Right. Not irrelevant, but, oh, what's the word for it? Negligible. There you go.
Negligible.
The difference would be negligible. Positive infinity. Give me an example. What's a function?
Oh, x squared plus 3x plus 25 over.
Can we just go stop at 3x?
No. X over x
But
squared
why? It's approaching, it's not?
x squared. No. Oh, x. You can just do x plus 25.
Couldn't we have stopped at the polynomial?
No, we couldn't have.
We could have. He was making up his example. Give him creative license. Okay, so the limit as you go to infinity is infinity. The limit as you go to negative infinity is
Is infinity because the top is squared. No?
negative infinity squared would be positive infinity, but
Okay,
negative infinity plus 25 is going to be negative.
that's true.
So we
True.
shouldn't put that under the positive one then? Oh, just kidding.
Does that make sense?
Yeah.
So positive infinity is squared plus 3. Now remember, we're doing pretend. We're seeing what's going on, is how our book would say it, literally seeing in quotes. We're seeing what's going on as we go to infinity. But please, 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 just be careful with that,
This time.
all right? We're not simplifying these, we're not like factoring, we're not making them equal to, but we're saying the end behaviors will be the same as. Negative infinity,
Oh, I got you.
struggle. Didn't we kind of do both?
Make Jackie do one.
Yeah, just put a negative in front of that one sucker.
Jackie,
I don't know.
You don't know?
Maybe the same as the positive infinity.
yeah, we could basically, right, because it has a negative infinity. What if we were just to do something like,
Yeah.
Yeah.
we could steal and do that. He was right though, and that's, Amanda, you were asking that too, like, this one's kind of cheating. Yeah, okay, you're right. But this one will be negative infinity for both, right? Do they have to be the same for the limit to exist, going to infinity and negative infinity?
I'm confused with the question.
Remember, usually they have to come from two different sides towards limit is approaching, x is approaching a certain constant, and they have to agree. Do these two have to agree? Like, is that a problem?
No.
Because they're two very different problems, right? And two different problems can have two different answers. Okay, now I need a limit that does not exist.
Miss P, if we
this
get rid
is
of we get rid of the denominator in the second one.
Then it'd both be positive infinity.
Yeah.
I mean, I still
I
like
got
the
one.
problem.
Okay.
I got one.
But, yeah. But,
Square root of x as an x approaches infinity.
kind of. Because, I'm
'Cause
going to separate. I want two different examples. We could do square root of x, because as you go to positive infinity, it is going to be infinity. As you go to negative infinity, it
D and E.
does not exist because
You can only do it.
x is greater than or equal to 0. But what's another one that does not have a restricted domain, and yet the limit does not exist as you
one
go
over
to
x
infinity
cubed?
or negative infinity?
ln of x.
No, because that'd be the same as this one. ln of x has a restricted domain. What's a function without a restricted domain?
1 over x cubed.
Oh, I got
You're
one.
thinking cubed root, but that would still be positive infinity, negative
Oh, I
infinity.
got one. I got one.
What's the one that
Cubed
goes
root of
like?
x, sorry.
No, I'm trying to think. The basic.
1 over x?
Is that 1 over x?
But he's going to 0 and going to 0.
Oh, x, no. I'm trying to figure, I thought of one with a hole in it, but that doesn't really work.
It's a function that doesn't approach any set
Wait a minute.
constant as you go to
Like forever so.
Sine.
Yep.
Sine.
Now, as it goes to infinity, we still can, even though it doesn't exist because it doesn't approach a single constant, what range does it still keep on
1 and
going through? 1 and negative 1.
Mhm.
So when we'll talk about that soon. Okay. So in all the ones above, nice, in all the ones above, let me change this to be a black line. Okay. Where or when did horizontal asymptotes occur?
When the exponents, when the leading coefficients are equal.
No.
Not the leading coefficients, when the
The power.
The
Degrees.
powers. That's,
Yeah,
what,
yeah,
that's what I meant to say.
I
For
know.
some reason-
You're thinking ratio of leading coefficients.
There you go.
When the degrees are the same, or, and we don't actually have an example of it up here, although George did start to say it. Oh, we did, and I erased it. Or when the bottom wins.
Bottom one.
True.
Yeah. Yeah. I'll go with the bottom ones.
So horizontal asymptote, yes, we have degree tests, that's very true.
Those are so.
But something that we need to keep in mind, and especially with this first example that I gave you, there could be more than one. True? There could be one horizontal asymptote going one direction, another horizontal asymptote going the other direction, and it almost always occurs when you have some sort of absolute value or square root. No way. We did too much today.
It's still limits. We'll do the homework. Unless.
Still try the homework, but
Yeah.
stink.
I mean, it's just
That's
a
okay.
review.
Can you just like skip to the page where it's like my equal answer the question that from earlier in 17? Maybe.
Okay, it's right here.
Squeeze theorem.
Squeeze theorem. Technically, there was a squeeze theorem from, and I stole this out of theorem number 4, out of section 2.1. We just didn't really talk about it because, to be honest, we didn't really need it. Technically, the limit as x goes to 0, sine of x over x comes out of the squeeze theorem. Similarly, the squeeze theorem holds for limits like or as x approaches positive, negative infinity.
Sin it ever.
Good question.
No, it's not an endeavor. We don't have to memorize the squeeze theorem. It's more of just an understanding.
Isn't that what the?
What do I mean by that? What do I mean by that?
You just have to know how to do
For
it.
limits, aren't we allowed to, and there's this whole like table of limits, you guys don't, I'm showing real quick, okay? There's a whole table. We don't have to memorize it, we don't have to write it down, it's more of an understanding. There is a quotient rule where we're allowed to take the limits separately and then compare as long as the bottom isn't 0, right? So when we come back over to this one, oops, wrong way. When we come back over to this one, the squeeze theorem still holds, which means as I approach infinity, what do I get? Cosine of infinity doesn't exist. So am I just totally stuck? I'm dead in the water? I can't do anything?
No.
No. I'm allowed to think about the top and the bottom and think about what's being squeezed in a sense. So if I think about the limit of 1 minus cosine of infinity, I know somehow cosine is going to be in between -1 and 1, right? But what's going on down here in the denominator?
It's going to 0.
It's approaching,
It's approaching.
right? It's approaching infinity. So if I think about, well, cosine is restricted and infinity is not, then question, who wins?
Bottom.
The bottom wins. And if the bottom wins, the limit is 0. Gerardo, that kind of has to do with my answer to number 17. We'll pick up with number 17 tomorrow. Start on homework, get as much done as you can.
Homework 4?
Yeah.
Yeah.
Start on homework number 4, Los Santos.
So cool. We're already on the.
And I'll have it updated by the end of the day. So you need the answer.
I mean, who does honors pre-cal think they are getting ahead of us?
Misty, can you make them fall behind like you made us fall behind?
It's not like